So yes, I am Amrith. I am currently principal scientist at SML. I did my PhD with Professor Goyal back at IIT Kharagpur. Then I was a postdoc at ITU Copenhagen. I was a postdoc at University of Cambridge. After that, I have worked as a staff scientist in a conversational AI unicorn called as Unipod. After that, I have been trying something of my own for a few months, and currently I am a principal scientist at SM. So I believe the links are available now. Himanshu, are you there?
Yeah, links have been shared on Discord. All of you have got
Right.
that? Yeah.
No. So what I have shared is essentially a GitHub repo. So I was thinking of facing this hands-on session in two separate phases. One is basically a bunch of Hugging Face tutorials, which all of you would be able to run in your own collab accounts. The second is basically an overview of how to get started with LangChain, where I believe you might require some sort of licensing. So for the time being, please bear with me. I will probably be able to demonstrate what can be done. And then, once it's offline, you can probably try your own. I hope that works. So I believe the drive is accessible to everyone. So you should be able to see these 5 files. So before getting started, I would recommend everyone to have everyone to check out some of the interesting notebooks or tutorials that Hugging Face have provided with. So is it okay if can I get a quick show of hands, like how many of you have previously worked with Hugging Face, especially with say training a model or something of that sort? Wow, that's quite a good uh, size of population there, I believe. So great, that's great. And how many of you have previously used something like LangChain? Again, that's a good show of hands. So that's really great. So it will be great if you can make it interactive. Please feel free to ask questions. We can make it interactive. We can try to do some modify stuff or play with this as we like it. So so I will start. So I was thinking I will start with probably this is covered in the lecture, like what are some of the fundamental categorization when it comes to the models that we use in today's settings. So while the history of AI is quite vast, I have constrained myself to using transformer-based models for the scope of this hands-on session. And basically, we are going to look into encode-Rowley models, decode-Rowley models, and seek-to-seek models. And we see what kind of tasks can be performed with this. So I will be starting with the first one, which is the task summary. So I believe the notebooks are accessible to everyone. Is there any issue in accessing the notebooks? So so please let me know if that is the case. Otherwise, I will start. I will proceed. So yeah, let me take care of the basic setup. So we are basically installing the necessary libraries. So in this case, I'm just installing transformers and data sets, both of them from the Hugging Face team. So from Hugging Face terminology, I will stick to Hugging Face terminology. These need not always correspond to the technical terminology, but I think these are more or less like it can be followed more or less from what we are trying to do. For example, here causal language model, what we mean here is basically autoregressive models or decoder only models, where we predict one token at a time based on a context of previously given k tokens. So an easy way to do this would be that in transformers, one could use the pipeline as one way to get things started. So if you look at the pipeline, it's very simple. All I want to do is, given a prefix or given a context, I want to generate a sequence of 30 tokens. And for that, I would call something like text generation. So I would initialize the pipeline with text generation as my target task. And I would simply call that generator object for it to generate the corresponding sentence. So we can see that we started off with, hello, I am a language model. And we can see what are the top 5 sentences returned by the GPT-2 model. So I have loaded GPT-2 model here. So with GPT-2, it will be runnable in your own collab notebooks or collab environments as well. So you could see that there are the various sequences generated here are, but what I am really doing is making a human readable document. There are other languages. Another completion is that I am a language model, not a syntax model. That's why I like it. I have done a lot of programming projects and so on. Now, the benefit here is that if you look at this is quite abstract. It's quite convenient. It's quite easy. All I need to do is that, yes, if I want to generate text, I have to just mention that in the pipeline. I just have to give the prefix. I have to say what is the appropriate length, and I just need how many candidates I need. It's pretty straightforward, pretty abstract. This enables you to use it as is without really getting into the fundamentals of how this model works. Now, if I want to get a little bit more fine-grained into or if I get a little bit more specific when it comes to the usage of model, transformers let you do that as well. So what I mentioned here is there is auto model for causal LLM and auto tokenizer. So previously, all I needed to mention was that I needed to do text generation. I didn't care whether there was a tokenizer or not. But now, if I look at a little bit more detail, I could see that as there is something called as a language model, and there should be a compatible tokenizer. But if you look at Hugging Face, the benefit here is that depending on the model, it chooses the relevant tokenizer for you. So all you need to do is just call this auto model and the corresponding the end task or the type of prediction you need or the type of classifier head you need to use. So here again, I am using GPT-2. That's what we were mentioning here. But this time I am loading the tokenizer separately because tokenizer is typically that converts the input into a sequence of tensors and help you get back the output into a string format. And the model is the function which processes or which does the forward pass for your input or the sequence of tokens or the sequence of tensors and get you the prediction. So I am initializing both of this into tokenizer and model objects. I'm providing my input here. So here I want my tensors to be compatible with PyTorch, and I'm passing it on to the corresponding device. In this case, since if you are in your collab setup, you will have a CUDA or a GPU at your disposal, else it may load in your CPU. So yeah, I am initializing the model for decoding or generation. So here I'm giving the input. I am constraining it to have only 50 tokens. And yeah, here you go. Okay. So you could see here, I enjoy working with my cute dog as my prefix. So, and I was mentioning that I need 50 new tokens, and this is the prediction. So it's definitely not a complete sentence, but you could see that you got the output for the constraint you have mentioned, or the limit you have mentioned. So what I wanted to highlight here was that, yes, we are getting into a little bit more detail. When we get into a little bit more detail, we do have better control. So from just understanding the pipeline, now we have seen how to use the corresponding model and the tokenizer. But as we know, we are using GPT-2. So if I want more fine-grained control, I can go ahead and do that as well. So here, I am using auto tokenizer, where the system is supposed to tell me what the tokenizer is, or Hugging Face's internal abstraction is going to tell me what the tokenizer is. Here, I am taking that control explicitly, and I am using the tokenizer designed specifically for GPT-2 because I'm calling GPT-2. Similarly, I am initializing GPT-2 model instead of the auto model, and I am going to use that. So it's the same prefix. Rest of them are more or less same. I am initializing a tokenizer object, model object. I am giving my input. I am generating the prediction based on the input. So as you may observe now, we are getting an error. The system is somehow not able to understand what is happening. So what it says is that there is a type error, because according to the system, the GPT model does not have generate function, or it is not compatible with the generate function. So there is no proper implementation that would let you use a generate with the GPT-2 model. And it also tells you the reason, that it tells you that there is no language model head attached with the model. So it won't let you use the generate function. So what I wanted to highlight here was that so understanding the concept is one thing, but when it comes to programming, it is very important to have this kind of separation, this kind of modularity that would let you that would let you generalize the same functionality across multiple models, and it also help you get more control over what you want to do. Only thing is that it makes it more complex, making it much more difficult for us to, let's say, or compelling us to be a little bit more disciplined when it comes to the programming. So can anyone tell me how can we fix this? So is there a way I can hear the candidates? Is there a mic or something?
Hello?
Yeah.
Yes, sir, we have mic.
Great. So I will appreciate, it will be great if anyone can tell me how can we fix this error? Is there a way to fix this error? So is everyone able to see the error here? Can I get a quick show of hands? It's readable to everyone, I believe, right? So, or if you can see that also, I mean, you may be able to see that if you are able to run it yourself. So it clearly says something here. So the designers of the library has been quite detailed when it comes to how they mention the error messages. So what they are saying is that what I used as GPT-2 model is not something that is help me do text generation. Because if you look at this, we were trying to do text generation. We were just trying to do it 3 different ways. And GPT-2 model is not the best model to do that, or it is not a compatible model that will allow text generation. Instead, it is suggesting me to use GPT-2 LM head model. So I am going to replace GPT-2 model with GPT LM head model. And I have to change it here as well. So otherwise, the methods are, since the classes are inherited from very similar base classes, I think the functions are more or less same. So let's give it a shot now. Yes. So if you see here, we are basically getting the same output as the previous one. So now it's just a choice of convenience versus control. So what I wanted to bring into your attention is that, yes, a typical tutorial that you will see will probably be making it very easy for you. It may just show you with this an auto model or a pipeline, but yes, getting more clarity into the details would give you more control. For example, instead of text generation, now I'm curious, what else can I use my GPT-2 for? Can I use it for, say, sentence classification? Can I use it, say, something called as for named entity recognition, right? So how do I know that what all are available for me, and in what different ways I can use the system or use this particular library? So I will go to the documentation of GPT-2. So now if you look at the GPT-2 documentation, you can see the base model is the GPT-2 model, which I initially invoked. But unfortunately, it does not have a language modeling head. So what they have done is that they have multiple such classes defined here that enable me to use it for different purposes. So as you can see, GPT-2 model LM head, it's basically a linear layer with weights tied to the input embedding that let me do the text generation. Now, if I do something like GPT-2 for sequence classification, what it does is that it has already programmed it in a way where it uses the last token in order to do the classification, which is typically the CLS token. So it uses the last token in order to do the classification, and that is how it does for other causal models as well. There is something called as token classification. So here, if I want to do a prediction for every token in my input, because if you look at sequence classification, what it does is that it takes in the whole sequence or whatever you give as input as a whole sequence as a single input and predicts a single label for this. But when it comes to token classification, I want to do, let's say I have a requirement where I need to get tokens for individual parts of the sequence, or maybe some subset of the sequence. It need not be for every token. The requirement may not be for every token. It can be for different subsets of the input. And how we achieve it? We achieve it by classifying every individual token in your input. So yeah, so coming back to our repository. Yes. So now what we have been talking so far is an autoregressive model, GPT-2. It predicts one token at a time. Hugging Face also supports masked language model or encoder only models as well. So if you see here, the difference here is what we mean by an autoregressive language model is that there is if you look at the input, there is always a context. It starts with, let's say, new. Then we expect it to predict York. Then we give New York, it expects it to predict East. So it is basically predicting either from left to right or right to left. And it is used to predict one token at a time. Now, if you see masked language modeling, the order doesn't matter. You can give an input by corrupting some part of the input, and you expect the system to predict the corrupted portion or the masked portion. And you do, so the benefit here is that, yes, we can use context from both the directions in a natural way. So now let me show you how we will do that for using Hugging Face. So if you're looking at the pipeline, we are looking at fill mask. And here, if you see, I have not mentioned what model to use. So this is the most abstract way I could use this model. So if you see previously, I have mentioned that I specifically need GPT-2. Here, I didn't mention that. I could definitely mention something, but I could just add a model argument and add what model I will be using. But nevertheless, the system have a default argument which goes to Distill Roberta base. So the system is using Distill Roberta. So again, Hugging Face is quite detailed and quite to the point where they say that if you're doing this in production, yeah, please don't leave this for the model's decision or the library's decision. We should give as much control as possible. Yeah. So now how do I do it? I have a context here, which is my input sentence. Hugging Face is creating a mask. This is my mask, and says that the community uses to solve NLP tasks. So now let's see how does the system predict the masked one. So if you see here, Hugging Face is creating a tool, framework, library, or database. So it gives different options. Am I still audible? Am I audible?
Yes, sir.
Yeah. Yeah. So now let's see how we will do the fill mask with the same level of control. So I will start with auto model for masked LM, auto tokenizer. So here, yes, I am mentioning a model. I am mentioning what do I need as my tokenizer, what do I need as my model. I am providing my sequence, and I am calling the system for generation here. So if you can see here, there is a tokenizer getting called that converts the sequence into tokens. We mentioned where the mask token index is. We get the logics for the model, and then we just print the predicted sequence. Now, coming back to what we discussed in terms of various applications. So if you see, we have been looking into language modeling, very specifically text generation. Sorry. Where text generation is open-ended text generation. It is to create a coherent portion of text that is a continuation from the given context. From there, let us now look at sequence classification. So sequence classification is the task of classifying sequences according to a given number of classes. So here the task now have changed. So here we take an input, we encode it using probably the same pre-trained models that we have seen. We have seen a GPT-2, we have seen a Distill Roberta. So now if you look at the documentation for GPT-2 or Distill Roberta, it allows me to do sequence classification. So it's compatible. So if you see here, yes, it allows me to do sequence classification because there is a definition for that kind of class. So yes, it lets me do that. And what is sequence classification doing? So in sequence classification, it is basically we have to predefine the number of classes that we are looking at, and we have to train the model by giving examples for each class. So we first define a label space. So for every label, I need to give some examples, and I use that to train my model. And once I train my model, I just have to give the input sentence and see how the system predicts. So whatever the system predicts, it is going to be probabilistically distributed across the classes it has seen during the training. So if it's a binary class classification, then it implies that we have provided only examples for 2 labels. So the system is always going to predict one of the 2, or in other words, system is going to give me a probability distribution over 2 separate classes. So again, I'm relying on the pipeline, and in pipeline, sentiment analysis is a standard task. And I'm using, so I'm not mentioning the model. I'm not going to go through the documentation to mention the model. It's the lazy way of doing things. And I am initializing the classifier as the object. With classifier, I'm giving the input. And let's see what the system predicts as the result. So again, the system chose an appropriate model, which is a Distilbert-based model, which was fine-tuned on sentiment analysis dataset. So SST2 is a binary classification dataset specifically for sentiment analysis. And since I have used the word hate, or in general, if you look at the overall sentence, this is a very easy giveaway. So the confidence is quite high. System says with 0.9956 confidence that this is a negative label. Now, if I change hate to love, so the sentence is the same. I love ice creams instead of I hate ice creams. That's the only difference. The system or the classifier gives me a positive label this time, again with a high confidence. So this is how we typically do the sentiment analysis. So here, we have not done any training. I'm just showing you how we do prediction here. Here, this is the laziest way to do it because I have not mentioned what kind of model I need to use, how many labels I have in mind. I have just used it as is. Now, I can do this the same way like with auto tokenizer this time. And here I'm changing my task. Here what I'm doing is that I am deciding that given there are so given there is a sequence, or given there are multiple sequences, I want to see whether something is a paraphrase or not. So here I am defining 3 sequences. The tokenizer will automatically, so here I am giving 2 sentences. If you see that I am giving sequence 0 and sequence 2, I am giving sequence 0 and sequence 1. So again, we are using a trained checkpoint at this moment. And the classes are not a paraphrase and is paraphrase. Now I'm taking 3 sequences in such a way that sequence 0 and 2 are paraphrases. The company Hugging Face is based in New York City. Hugging Face's headquarters are situated in Manhattan. And sequence 0 and sequence 1 are not paraphrases. So apples are especially bad for you. So these 3 sentences, we are giving them where we give a pair of sentences as input. This is the expected way of giving the input for this model, which is determined during its training. So models which are like bird-based models, or most of these pre-trained models, have used some form of special tokens to separate out sentences. So here, just using it as is will help the system determine where to put the CLS or the sentence separator. So yes, we tokenize not one sequence, we tokenize a pair of sequence at a time, and we give it to the classification system and we predict it. So now let's see what the system thinks it is. Yes. So for the pair where we gave it as paraphrase, So if you see here, paraphrase result is the result for paraphrase classification where we gave the pair as paraphrase. You are getting that with 90% confidence that it is a paraphrase. Similarly, when I run the prediction for the other pair where it should not be paraphrase, I'm getting the prediction as not paraphrase is 94% and is paraphrase is 6%. So are there any queries? I will pause for a few minutes. If there are any queries or doubts, please feel free to ask this time.
Hello. So
Yeah.
sequence classification,
Mhm.
performing sentiment analysis.
Mhm.
So is the Distilbert model able to capture aspect sentiment analysis? I mean, like the prompt given is I hate ice creams.
Yes.
If I
Yes.
gave I hate ice creams, but sorry, I love ice creams, but I hate going out. So be like aspect based sentiment analysis is not getting captured.
Yeah.
Here
Yeah.
it's giving a negative sentiment.
Yes. Yes.
So is there any model that would be able to perform that?
Great, great. Yeah, that's a great question. So now let me share the screen. Please keep the mic with you for a moment. So you were mentioning I hate ice creams, but can you say that again?
The second one, like first is the sentiment, the second sentiment. Like I love
Yes,
ice,
yes, yes.
but
Yes,
I
it is like, yeah, but I,
hate going out. Like
okay, okay.
real sentence
Yes,
two emotions.
yes, I got it. So,
The second
so yeah, I love ice creams, but I hate going. So this is going to be a googly for the system also because now you have both the keywords, right? Yeah. So let's first see. So the system is going to predict it, say whether it is positive or negative and nothing else, first of all. So now let's see whether that is going to be done here. Yeah. So the system thinks it's negative. So maybe let's try giving the word order differently. And this gives the confidence to be also quite high. So I hate going out, but I love ice creams. Okay. So from this, I think I will conclude. I will not conclude, but at least my initial hypothesis would be that system is giving priority or bias towards words that appear later towards the sentence, later towards your input than earlier sentences, the words it has seen in previously. Now coming back to your question. So when I mentioned sentiment analysis, I didn't mention a model. Now, if you see, the system has decided to use one model based on the coding the developers of the library has decided. So they have decided to take Distilbert base uncased fine-tuned SST2 English. So if you see here, this is not a general purpose language model. This model is a task specific model. So by task specific model, what I mean is that you had taken the BERT. BERT is, again, we can say it is general purpose, but we have first of all added something towards the end of the model called as the classifier. So if you see, we have mentioned that also, right? We have said that I don't want the normal model. I want a model that is very specific for sequence classification. So what does it mean that? It's like the general purpose BERT along with a classifier head added to it. And that classifier head also is designed in a way that it only has two classes. It either has the positive class or a negative class. And who did that? The people who have built this, they have very clearly did this, what you call as like they took the Distilbert base model, they added a classifier head. Then these two combined were exposed to sentences that either had a positive or negative label. And the task here is that I need to provide exactly one label for the class. That is very clear. So this is basically a instant. This is basically, this model is a very task. It's a task specific model. Like it does exactly one thing, what it is trained to do. So to answer your question of aspect based sentiment analysis, in machine learning terms, that becomes a different task of itself, because your input might be the same, but your end goal or your output requirement is different. I think you have mentioned that you want to know emotion, the sentiment for individual words, or at least you want to highlight words which have an emotion, and you want to identify what emotion that word is, right? That what sentiment that word is. So that means we have to train a different model for that. And Hugging Face enables you to do it. And that actually is very similar to a token classifier. So in token classifier, what it does is that, let's say, if this is your sentence, okay, let's say the system or the tokenizer tells me that I is one token, hate is another token, going is another token, out with a comma is another token, but is another token. All right. So then I will design this task to be doing something like this. I will say for the first token, I need to know what is it. So I will say it is neutral, right? I want it to be neutral. This has to be negative. Going again is neutral. Then I would want the love, a lot of them to be neutral. I would want the love to be also, love to be positive, right? Ice cream again has to be neutral. So if this is your end goal, right, then instead of using something like sequence classification, I should go and use something called as token classification. So does that answer your question?
Yes, sir. Thank you.
Sure, sure. Okay. So some of these are standard tasks in NLP or in AI in general. So Hugging Face have already implemented for them. But if there is something which doesn't fit into the standard task, then we will have to write our own definition for, we will have to inherit one of these classes, we will have to write our own definition, and we will have to train the model. That will be an added complexity. So are there any other questions? Sure. So a quick summary of what we have been doing. We have been looking into language modeling. We saw there are two ways of doing it: the casual language model, the causal language model, and the autoregressive model, and the masked language modeling. We were looking into very specific set of tasks. So we are looking into models that are trained to do one thing, but we be very good at that one thing. And we don't do it from scratch. We take general purpose models or the foundational models, and we attach a classifier head or the necessary mechanism to train it for one very specific task. We have looked at text generation. We have also looked at sequence classification, which is classifying whether a given input is belonging to one of the K classes. Now, as we were discussing, like if I have a different requirement, even for the same input, I might have different requirements depending on the downstream application that I have in mind. So named entity recognition is typically an instance of token classification. So what is named entity recognition? It's pretty straightforward. If you see here, there is a input sequence, there is a passage. You can see that there are different kind of proper nouns or entities, as you may see, exist in this sentence. And we need to identify which of them are entities and what type of entities they are. For example, Hugging Face is an organization. New York City is a place. Dumbo is supposedly a place. From the sentence, we should mention that. Manhattan Bridge, again, is a place. So we have to, from the sentence, we have to identify which of them are entity and what type of entities they are. So let's see how we go about it. So let's look at the lazy method, the pipeline method. So in pipeline, named entity recognition is a standard approach. Again, I am not mentioning any model. So Hugging Face decides this is the best model to go through or to choose. And this model have these many labels. So there is something to do with miscellaneous, person, location, and organization. So now let's see how we use it. So I'm giving this sequence as input. So now you can see what you're seeing is that, first of all, the sentence is tokenized into individual tokens. And you may see that the way the classifier, or say where the foundational model sees the sequence, is not the same way we humans will look at it. So for a human, hugging is a single term. It is very easy for us to say that Hugging Face is part of the same entity. It is very easy for us to say that New York City is one long, it's an entity, it's a single term, it's not multiple separate words. And it is also very easy for us to say that company is a word. But if you see here, the classifiers do not have a correspondence with the human understanding of the vocabulary. They have a vocabulary of their own. Their vocabulary is learned again from data where their definition of a word is nothing but with any character combination which is frequent enough in their data set. So that is why Hugging Face is not a very, at least for the data set that they were using, which is the Cornell 3 data set, or the overall data set that used to train the BERT model. According to that, Hugging Face is not a very common or a frequent word. So it has decided to split it into smaller words or smaller subwords, which it has seen frequently enough. So that is why hugging is now separated as ha and ging. And for as humans to retrieve back it in the original way, the system is adding some symbol saying that, hey, this is not a complete word. It's not a beginning of a word. It has to be merged with the previous word. So yeah, so that is how the system tokenizes. And you can see I'm only showing those tokens which have a label other than O. O means there is no entity, but every other token here have some or other entity label, which you can see here. So we have done this tokenization, and here now what kind of how will the code change if I want to do token classification, where I'm classifying every individual token instead of the whole sequence? What should I change? It's very simple. I have to just change it to auto model for token classification. And since I am using a BERT model, I can just call BERT for token classification. So instead of using this auto model, I have decided to take things into my control, and I have decided to call BERT for token classification and BERT tokenizer first. And let's see how the system behaves. So this is the input sequence, and let's wait for the predictions. Okay. So now the final result is in the predictions. And when I do this prediction, you can see that it's basically a list of integers. So there is an integer for every input token, and each integer is basically a class which we have defined. or which we have defined during the training. So this is a seek token or a label for every individual token in the input. And if I have to make that change, here it is. So this is how the sequence looks like to the system, the first entry of the tuple. So we start with the start marker, then there is hugging face, then there is individual words. And the system has given the corresponding prediction for each token. Now, if you see, there is something that the system has given me a warning of. So the warning, if you run here, you will see that I am somehow not calling the correct head. And I have to see whether this is all right, because system is not able to tell any better. So this happens because if you see here, even though I am using a BERT model, and this is a BERT for, I'm calling the BERT for token classification, which is the correct class. It is still giving me this warning message, because if you see here, this is a model fine-tuned by a third party. It has nothing to do with the original BERT developers, or it has nothing to do with the Hugging Face developers. Anyone can fine-tune the model, anyone can update the model and train it for a very specific task, and they can upload it in Hugging Face. So this probably is the challenge we can see here. So this is why the system is probably mentioning this. So just to be sure, what I do is that if I call the auto model for token classification instead of this one, this issue should be more or less fixed. So I want to understand what kind of classifier or what kind of object is being called by this auto model. For that, I am importing auto config. In the auto config, I am giving again this, right? And I am predicting that I am printing out the config. So if you see here, this model has only one possible option as an architecture, which is the token classification or as the option. Since it uses BERT for token classification, even with auto config, I can confirm that yes, this is the same that I have used. So there is nothing to be worried about. It is just a generic one. So if you see here, you can see what all does the designers of this model have defined for the model from the config. So you can see that what were the labels they have mentioned, what are the different other hyperparameters that is available, all those info, all those configurations you can see. Now I will quickly move to another task called a summarization. Now, summarization is a task where you give a long input paragraph or a document, and you expect that to be summarized. So let's see. Yeah. The system again is choosing something of its own, because I just mentioned that I need a pipeline with summarization. And yes, so let me try to see summary. Okay, for there is some error coming here. Yeah. So here again, I am mentioning what should be, I mean, I'm running the summarizer with the input. Yeah, is there any question? Yeah, okay. So I'm using this. So basically, yes, I use this summarizer, which is an instantiation of the pipeline summarization, and I'm getting the summary. Now, if I have to do that for my own with a little bit more control, yes, I'm using the auto model here, auto model for seek to seek LLM, seek to seek LM, and I am using T5 base. So T5 base is another model that enable you to do this. Now let's see how does it do the summarization. So if you see here, there is a summary that comes out of the seek to seek model or the T5 model. Now I will take a moment to go and see the documentation of T5. So if you see T5 here, I can see for what all purposes I can use my T5 for. So I can see that T5 can be used for sequence classification. I can see I can use T5 for token classification. I can see I can use T5 for question answering. I can see I can use T5 for conditional generation. Now, if you compare this to a BERT, so remember we have used a BERT or a distilled BERT for our uh, sequence classification and token classification. So if you see here, BERT also have classes defined for sequence classification. It has class defined for token classification. But curiously, if you see here, you wouldn't be able to find class defined for conditional generation. So what does it mean? So this is where the beauty of this library's design comes into picture. The difference between a BERT and T5 is in its architecture. BERT uses masked language modeling, while T5, and it's an encoder only model. And if you look at T5, T5 is a seek to seek model or an encoder decoder model. So it has a separate encoder that encodes your input and then provides a output using decoders. So, oh, sorry. Yeah. So that is why conditional generation is something where it is very specifically designed for encoder decoder models, because you need to have something to be conditioned on, which is at the encoder side. And then we do the decoding. So this class is defined only for models which have an encoder and a decoder explicitly, and we use it. But the same models are also feasible to be used for sequence classification or token classification. So these are defined for them. So I will just quickly go ahead and show. So now the another beauty of Hugging Face is that it is again designed in a way where you abstract out the type of data. So you can have models in Hugging Face which is used for audio classification, which can be used for automatic speech recognition. I will skip those primarily because I will not be able to play the audio. So I will rather show you something with the image classification. So here again, they have well-defined pipelines where if I want to do image classification, that is there. And I am using one of their standard data sets where you can see what are the classes and what are the scores. And just give me a minute. Yeah. And let me now first load one of these data. So here, if you see, the Hugging Face have decided to use the Google VIT based patch model. It is an image classification model. I am loading this data set and I'm just seeing, okay, what is this image? So this image is that of a Persian cat, as you can see here. So now I will use this model. Again, if you see, instead of the pipeline, now I can have greater control by using this image processor and more image classification model. I'm specifically calling Google VIT base patch model. I am taking my image, converting it into, again, a tensor using a feature extractor. And the feature extractor is again defined within, based on the model that we are using. And let's see. Yes, so the system mentions what is in the image. So it's an image plus, since it's the task we did, it was image classification task. So Hugging Face is a highly recommended library when it comes to building models, when it comes to building all sorts of, let's say, neural models or transformer models. But its utility exists when you have to train your own models. Again, whether it is the LLMs, whether it is the foundational models, whether it is the task-specific models like the ones we were looking at, or I can take a foundational model and train it, fine-tune it to be used only for a specific task. These kind of purposes, it comes as a very handy library which has integrations or which wraps around both PyTorch as well as TensorFlow. So if you see, there is a TF prefix implying that you can use this model to train the corresponding seek-to-seek model in TensorFlow. So yes, so I will just quickly go through the training setup if I have to train a model in Hugging Face. So if you see here, so in the training setup, we first have to decide what are the labels we are going to use, what is our end goal based on which the labels have to come up. We have to provide some example inputs to the model saying for a particular label, what are its corresponding inputs. And then we have to do the training for the system. So if you see here, I am taking a Yelp review. And you can see here that there is a label also provided and the text that is provided. So irrespective of whether you're doing prediction or whether you're doing training, the forward pass or how you get the initial prediction is more or less the same process. So yes, I am first initiating my tokenizer. I am tokenizing. I am getting my data set. Then, yeah, just give me a minute. I have decided my training data set subsets. I am giving my training arguments because here I have to see where should my model be saved after training. What are the other parameters to be looked into? What should be my batch size? What should be my update interval? All those things. I have to also keep a track on how well the training is going. It is typically done via monitoring the loss. And I need to know after the training, I need to evaluate how well my model is performing on an unseen data set. So I need to have the corresponding facilities or features for evaluating the model. I'm using accuracy as my metric. So I'm defining how to compute the accuracy. And finally, I am calling the trainer. So here I am mentioning what is my base model. What are the training arguments to be taken care of? What is my training data set? What is my eval data set? So eval data set is a validation data set, which we use to keep track of how well the training is progressing. And then we finally give the metrics, which we obtain via the validation data. And once all of this is defined, all you need to do is just to call the train function, which will, depending on the task, depending on the model and the compute, which may vary quite hugely. It may vary from few minutes to few days or even few weeks. So this particular one, it may take I think half an hour or 2 hours. We will not get into that. But the benefit of Hugging Face is that it is a full-fledged app that, or a full-fledged library that enables you to train your own model, host your own models. So this is highly recommended, and it is highly integrated with PyTorch and TensorFlow and other standard libraries used for training such models. So again, it's highly recommended to have a look at different notebooks that is available. It tells you how to do several of these tasks, whether it is with the sequences, audio, image, all sorts of tasks you have in notebook. And if it's not sufficient, there is enough that is contributed by the community as well. So please feel free to have a look at it. So now I will quickly shift to some use cases with LangChain. Before that, are there any questions? Are there any doubts?
Hello, sir.
Yeah, hi.
What is the difference between BERT-based case and uncase used in when doing?
Sure. So see, I will first give you the very specific answer, which is like when you say bird base case and bird base uncased, the only difference is case and uncased, right? So what happens is that, see, we understand what is a capital letter, where to use a capital letter, and we know what is the difference between capital A and small a, right? It's very easy for us to distinguish. But to a system, it's all symbols, right? So I want to see whether I want to use my data with that capital letter information or without the capital letter information. Because if I'm using my capital letters, then my alphabet is easily 52, right? Because I have 26 small letters and 26 capital letters. Each of them are separate. And I'm also losing some information of like the system is not capturing that part. Capital A is corresponding to small a. It treats them as separate symbols, right? But when I do the casing, what happens is that I forgot which one is what, but basically in one case, I am converting everything into lowercase. In one case, I am retaining the original case information. Now, where is it useful? If you look at named entity recognition. So what is named entity? They are named, they are proper nouns. If you look in English, proper nouns always start with capital letters. So if I have to do something like entity recognition, it is advisable that I use the version where the small letters and the capital letters are both exist. But if I want to do more from document understanding where this capital information is not helpful, then I can use the version where I don't need the case information. Largely, these are design decisions that the people who have trained these models have taken. So does that answer your question?
Yes, sir. Thank you, sir.
Okay. So are there any other questions?
So I don't think any more questions from.
Sure. So I think we have half an hour, right? So we have been so far looking into Hugging Face. So as we mentioned, Hugging Face is typically used when you want to train your own models, when you want to build your own models for very specific use cases that you have in mind and you have enough data. But thanks to large language models, thanks to foundational models, which are quite large, where it can do a variety of tasks decently, nowadays we have libraries that support building AI powered applications without really doing any of the machine learning stuff, without doing any of the training. we can build AI powered applications, and they typically use a large language model like ChatGPT or Hanuman or Cohere's, I mean, the cloud models or any of those models. And the difference here is that it is very easy to prototype in that these models can be used for vastly different type of tasks. But the moment I have a specific need and the moment I have some data for it, the specific model or the specialized models tend to outperform the other models, the generic models or the large language models. So that is where the distinction is. But if I have a use case and I don't want to go to a 2 to 3 months of data annotation or those kind of pipelines, I can easily build something using a large language model. So it has its own use cases and it works really well for a variety of tasks. Some of them which have not been explored previously. For example, chatbots are there for few years, I believe, but of recently we are hearing a lot more about agents. So does anyone know what is exactly the difference from a business viewpoint? What is the difference between a chatbot and an agent? Does anyone like to volunteer and respond to that?
Yeah, agent is like it has more control. It can do things. If you can ask to
Yes,
calculate, it will has access to
yes,
calculator. It will have access to Google search. So those are agent.
yes, yes. So agents enable you to do the stuff. For example, if I have a chatbot for say flight booking, a chatbot will tell me what are the prices, what are the all those things, but it will not do the booking for me. But an agent is something where we build it to do a particular, do the task also for us, which is like an automation, right? So that is something from a business use case the agents are used for. Now, again, from a business or a product use case, if you see, that means this large language model should be aware of the APIs that is available, right? I mean, if I have to book a flight via internet, I need to know should be a payment gateway, what that payment gateway's APIs are. It should also securely know, it should also know to load my credit card details and securely pass it through. So it means that it needs to know what are the relevant APIs and how to use them. So that again is a product use case where we need to equip these systems with these tools that will enable it to do this. And given the large number of parameters these models use, these are generally trained to do this very well. So let's have a look at probably one or two applications of LangChain where we do this. So let me share my screen. So if you see here, I am using this for one of the use cases, which is quite straightforward, which is basically reading. It's a RAG chatbot. So when you say retrieval augmented generation chatbot, so what it does is that it enables me to download, it enables me to take a paper, an academic paper, maybe not that interesting, but yeah, that is a good reason why we should summarize it. So it let me summarizes a paper, an academic paper, and provide me the summary for that. So here I am using it to download the file first. I am extracting the text. None of this is AI. It's just the standard PDF parser. I am making sure that, yeah, I have downloaded the relevant set of pages, which is 14 pages. I am extracting the text, showing me how the input output is. And I am extracting only the text. So if you see here, this is the text extracted. So now I will be using GPT model to do the parsing. So let's see how many tokens it amounts to. It amounts to around 19,000 tokens. I'm doing some pre-processing, like I don't want to have the citations, which is like the reference numbers. I don't want to have information, which is basically, again, additional information, which is not core to the content of the paper. And I'm seeing that there is some reduction of content. From 19,000, it has reduced to around 15,000. Now, let me use the LangChain as a library. So if you see, LangChain provides very limited set of functionalities if you want to train a model. I'm not sure if it provides any. I'm just being safe by saying it has limited functions. I have never used or seen any of it. The ability to train a model. This is largely, but it enables to orchestrate a lot of AI-powered application. That is the primary use case for LangChain. And as you can see, it is enabling me to do that. So since I'm using ChatGPT, as the name suggests, it lets you chat or converse with the LLM. And LangChain has very neatly defined some classes that enable me to distinguish between the message from AI, the message that the human gives, and the message that the system needs to know in order to understand the context better. So here I am looking for an academic paper summarizer. So someone has to tell the system that the ChatGPT, now you have to behave like a researcher so that you can summarize the paper well. So that is what I'm giving as the prompt here. You are a helpful AI researcher that specializes in analyzing ML and LLM papers. Please use all your expertise to approach this task. Output your content in Markdown. So I'm mentioning to the system that I have to give it as Markdown. So I'm then loading it as my system message. Then I'm telling, this is typically what I will take it from my user or a real human if I have to give it as an app to others. So here, the human will say, please summarize this paper, focusing the key important takeaways and whatever they want, and they will provide the paper content, which we have already extracted and kept. So I am again loading it as a template, and wherever there was a placeholder, I am replacing it. So I'm providing my template, which is nothing but a concatenation of the system message and the human message. I'm calling my ChatGPT via this function. So when you're running it, I think you might need to provide your own API, or you have to change it with the corresponding LLM if you need this to work. Unfortunately, I couldn't arrange for a open model that can be hosted. I'm just calling the chain that will enable me to do the summary. So once I do that, I am basically calling this model, and I am getting this output from the system. So this is something that I have done we're using this OpenAI or the LangChain. So now I will quickly go through and see how can I use it to extend this functionality, not just a summarization, but also to chat using the PDF files. So now it seems quite natural to us that, yes, if the model can summarize it, the model can also use it as a base to do the chatting. But the behind the scene design is a little bit different now. Now what I do, I will take a PDF, I will convert it into chunks, I will convert them into embeddings, then I will store it in a vector DB. And whenever there is a question, I will try to find passages which is most relevant to the question. I will pass it to an LLM and I will answer. And I will give it to the LLM, which the LLM will provide the answer. So this is what we plan to do. So if you see here, I am using PyPDF2 as my parser, PDF parser. I am using LangChains on input in internal text splitter. I am using files as my vector store. So I'm downloading a PDF and passing it on to the model and passing it to the PDF parser. So it has taken it as the parsed PDF as an object. And I'm adding it all, and I'm seeing that it's roughly this much. It's a whole book, so it's quite big. And you can see that, yes, this is the text that I have extracted. So now, as you can see, there are these many characters. It is like 3,71,000 characters. So I am dividing them into chunks of 1,000 characters each. And whenever I'm doing, I'm also taking the overlap. Like if I'm doing 2 chunks, then the second chunk and the first chunk will have 200 characters in common, respectively the end and the beginning, at the end and the beginning portion of those vectors. And yeah, so I am doing the split. You can see I have 466 such chunks. And now I am converting them into embeddings. I am using OpenAI embeddings itself to do that. And I store them locally using files. So here, this is the process of indexing them, because I'm taking a text, I'm converting it to an embedding, and it all happened in 10 seconds. So now, one thing I can do out of the box is that I can just ask this question: how does the GPT-4 change social media? And I can simply find passages which is most relevant to it. It's like a typical search. Only thing is that it's a semantic search. I'm doing semantic comparison between the embeddings and the input. And you can see the system has decided there are 4 passages, and these are the passages that you can see here. Once I do this, but our task or our app doesn't end here, because we need to do a chat. We need to ask questions to it one after the other. So for that, I am importing a predefined question answering chain from LangChain. I'm using this, and yes. So I'm basically loading the QA chain using OpenAI. And I am so this is the entire prompt that you can see here. So use the following pieces of context to answer the question at the end. If you don't know the answer, just say that you don't know. Don't try to make up the answer. So we are telling the system to hallucinate as less as possible. There is no guarantee that it will not hallucinate, but we are just since prompt is the only control we have, we are providing that. We are then providing the context, which will be the retrieved passages from semantic search. This is the question that the user has asked. Now let's see everything working here. So if you see here, these were the input documents. So the question was, who are the authors of the book? System found 4 separate documents where there are some relation to this question. The first one is that authors, themes, or perspective that comprise them impossible interview rate. I don't think it's very useful. Then there is Yella Machel and Sok Quinton. Thank you all for your time, insights, and encouragement. I would like to thank Reid Hoffman for inviting me to co-author the book with Reid. So it is providing this, but it is distributed across the different paragraphs. The course was scripted by Italo Calvino, and modern Italian process famous writer, probably not relevant. So we have provided all this context to the system, and the system has decided that the book is co-authored by Reid Hoffman and Mark D. Sistre. So it has taken the context from all these 4 documents, and it has defined this. Now, if I give a different query, like has it trained this week? So if you do the semantic search, it will still give you the top most similar documents. But here we have given that context to the LLM, and we have asked this question to the LLM. But this time the LLM has decided that it is not appropriate to answer that question based on the given information. So it says, I don't know. This is exactly what we wanted the system to behave. So this is all done via text prompts. So I will not get into this map reduce part. Instead, I think I will just show how we can use agents. So here what I'm doing is that I am not using one agent, but instead I'm using two agents. And here I am making both the agents do dialogue or debate. And when doing debate, I am enabling them to search the internet for their answers. So yeah. So again, LangChain has inbuilt mechanism for memory to keep track of the previous conversation. It enables to distinguish between AI message, human message, system message. It also have inbuilt classes for agents, depending on the different type of agents.
Can you hear me?
Yes.
Sir, one of student have a question, I think.
Sure, please.
Hello, sir. So
Yeah,
when
hi.
LangChain for summarization from the that academic paper, so
Mhm.
is it performing abstractive summarization or it is extractive in nature? I
Yeah,
mean,
that's a good question. So, see, the LLM, by its the way it is designed, it's always going to do abstractive summarization, unfortunately, right? Now, there are mechanisms where I mean, if I don't want it to do abstractive summarization, I can just use embeddings and use semantic similarity search to get that. I can also force the system to extract sentences, but the underlying architecture is still generating the sentences, even though, and there is not a guarantee that it will always extract. It behaves well, say for 99% of the time, but it is still abstractive, unfortunately. Even though whatever guardrails I add in prompt, there is always a chance of failure, or I will say there is no guarantee. So it's going to be abstractive in some way or the other. But yeah, by default, it does abstractive summarization because it is trained to generate one new tokens one at a time. So does that answer your question?
okay, so one more question. So
Yeah.
whatever libraries we are trying to explore here, are they specific to like rich languages, or they work fine with the low resource languages like Indian regional languages we talk about?
Yeah. See, the point is that the libraries are language agnostic. So when I say libraries are language agnostic, that is equivalent to say that if I have a pen, I can use that pen to write in any language, right? The only precondition is that the writer needs to know a language if they have to write in that language, right? So similarly, the language is the property of a foundational model. And it will not stop at language, it will also extend to modalities also. A foundational model, if it can understand multiple modalities, say images, speech, and text, and there are such models, then the libraries can support this. So multilinguality is supported by many of these libraries, so is more multimodality. I think there might be some additional effort required in designing multimodal support, but multilinguality generally doesn't require a lot of additional support because as far as the libraries are concerned, they just need to use Unicode. They don't care what the language is. That is the foundational model or the LLMs concept.
Okay, sir. Thank you.
Sure. So are there any more questions?
I think you can continue, sir.
Sure. So yeah, so I am defining agent. So agent definitely need to keep track of the conversation. Agent needs to perform actions. That's something we have started with, right? So let's start. So if you see here, there is a dialogue agent that a class I am defining, and I am I'm defining certain methods or functions within this class that let me handle this agent. So this is something like a custom agent that I'm building called as the dialogue agent. Now, if I have to extend my class to all my agent to use tools, I'm inheriting my base dialogue agent, which is a dialogue agent, and then I am extending it with tools. So here what I do is that I am defining additional functions that let me do that. So if you see here, I am just using this load tools. So I'm calling the constructor of its parent, and then I am adding its ability to load tools if the tools are well defined. So as one of you were mentioning that the tools can be a calculator, tool can be searching the internet. So I am defining the dialog agent with tools. Now I am defining the roles and topic. So I'm basically saying there are two types of agents. One is an AI accelerationist or an optimist, and AI alarmist, probably a pessimist or a critic. So I am mentioning what all tools they will be using. In this case, both of them will use these. Maybe if I added something like a conspiracy theorist, I might have just put Reddit as the tool. Nevertheless, the topic of discussion is current impact of automation and AI on employment. So now I'm defining my prompt here. So I'm asking an LLM to add detail on the topic description. So yeah. So here, my agents, both of them, whether it is accelerationist or the other one, whether the alarmist, both of them basically are instances of the same dialogue agent with tools. It's just that I am using them with two separate personas, which is provided via my string input, if you see here. So I'm using the same set of functions. I'm generating descriptions as well here. So the AI accelerationist is a visionary of digital evaluation, sees technological advancement as the key to unlocking humanity's potential. All those information. If you look at an alarmist, alarmist is a technophobe adorned with wrinkles of worry etched deeply on their brow. So if you see here, these descriptions are basically defining the persona for the different instantiations of the same definition of the agent, right? Now I am defining again my, so given that the description and the role or the name is like the custom made, the rest of the part of the template is, of the prompt is a template. So you're saying that the aim of this agent is to persuade your conversation partner of your point of view. You have to be looking up for information, do provide references, do not fabricate fake citations. We are providing all those ground rules, which is applicable to both of them. And yeah, so now we are starting this specific topic. So here, the prompt again, there is a moderator in the prompt, which enables to mediate between both the dialogue agents. So now I'm mentioning, yes, there are dialogue agents with tools. I'm using GPT-4, and I am initializing both my agents using the same loop. I'm keeping track of a function that enable me to understand the turn of the conversation. Like if turn one goes to the alarmist, the second turn has to go to the accelerations. And I am simulating this dialogue for 6 turns, and I am using agents. So if you see here, I have equipped it to use few tools, like, so one of them is DuckDuckGo. So using the DuckDuckGo, the system has come up with a query to search within DuckDuckGo. DuckDuckGo is a search engine. And based on that, it is providing a final answer where it uses this information. And we are doing it for 6 turns. So every time here the agent is not just suggesting that we can use DuckDuckGo. The agent personifies the particular persona that we have given it, and it is taking the action on behalf of that persona. So if the agent is asked to behave like an accelerationist, AI accelerationist, it is behaving like one. If it is not, then if it is an alarmist, if the persona is alarmist, it is behaving like one. but you can see how the input queries are differing based on the role it has assumed. So if you see here, someone started the dialogue with this query where it is talking about AI in manufacturing jobs, then it is looking for how it is alarming. And based on that, the alarmist has made its own final outcome. Similarly, the accelerationist has made its own outcomes. Yeah. So if you see here, this is the whole output where it is calling the DuckDuckGo, it is making an observation, then it is making a final answer based on that. This is something these models are equipped to do with. So yeah, so that's how we use agents with tool use. Again, since you are here at a summer school for machine learning, do try to understand that these large language foundation models have to be trained to call the tools. And if it is a large language model, text is the only way for it to use. But these models are well trained to understand patterns and convert them. So all we need is just the tokens that will enable us to do the further actions on calling tools. So yeah, that's pretty much from my end. So I think we are also almost out of time. So if there are any further questions, I'll be happy to take them.
Sir, I have one question.
Sure.
So when we were doing in the starting the named entity recognition part, so like large language models are generally claimed to perform well on subtasks like tokenizers and other subtasks. Isn't that New York City should be identified as a single term? Though it is identified the complete three as location in the name, New York City is a single term. Why it is tokenizing it as three different terms?
No, that is a good question actually. So let me go back to that particular part. So we are talking about this, right? Named entity recognition. Manhattan, New York City. So ideally, the system should have. See, first of all, the point is that there is a limit. We are using this with a very specific task definition, which is to predict a label for every token. Okay. So, and the system, the foundational model has decided that in its token, New York City is not frequent enough. So it is dividing it into New York and city, just like hugging is divided into ha and ging, which is not even meaningful. Here it has decided it will go with New York and city. So it should have, it will definitely be treated as 3 tokens. It might have been treated as 4 tokens also. It depends on the tokenizer, first of all. Now, when we design our labels, we have to design it in a manner where, if you see here, the B person, I person are basically a way for the system to tell that something is a starting point and something is a continuation of it. So unfortunately, I think the system here is predicting only I. It is not predicting anything to do with B. So that is an error from the system, which means that we have to train it better. So if you see here, if you look at here again, unfortunately, this particular model predicts everything with I, implying that it is what you say. It is based on the definition. It is only taking something which is it does not have a beginning token or a beginning label, which may not be a desirable thing. So that is an issue, which means that we have to train it better. But yeah, the overall limitation is that we have decided to use it as a token classification problem where every individual token has to be predicted. So if it has done it as per the designer's wish, then we could have done simple post-processing to show it as a single unit to the user. That didn't happen here. But even here, I can post-process saying that everything that is a continuous I log, if it is I can merge it and say that it is a single token. That is, I can show that. So it is enabling me in certain ways, if the predictions were fully correct, unfortunately, there are some inaccuracies here. So does that answer your question?
Yes, sir. Thank you.
Okay.
Hello, sir.
Yeah.
I have a question not relating to the hands-on session. In the
Sure,
introduction,
sure.
it was mentioned like you are working on creating LLMs.
Yes.
Can you just add some more light on what are you working? And
Sure, sure. See, foundation. So when I'm saying LLMs, so a more technical term here would be foundational models, right? And so I'm currently working at SML. So SML has already have an LLM called as Hanuman, which was released in last May, and it is a 300 billion or a 370 billion parameter model. It's a quite huge model. But apart from that, and we will have a multimodal model releasing quite soon. But apart from that, now what we are looking for is that we are looking for building very specific models for very specific verticals. For example, a chat GPT, it may do well on a lot of things, but the moment I want higher accuracy for a very specific domain, let's say I want to do something on medical alone, then it is advisable to build a medical LLM separately. Now, when it comes to a medical LLM, what is the requirement? If you look at an average use case, there is images because there are scan reports. There are genetic sequences, protein sequences, which means there are sequences. Then there is ECG, EEG, which are basically time series. Then there is text because there are documents, medical reports, right? These medical reports have a structure. They have tables. They have other sort of structured documents. Also, doctors might generally want to speak out and the system to do the summarization, which means there is speech. So that now we are talking not just three modalities, but more than three modalities now, right? So we need a system that can understand all of this and also to interact with the human in also several of this, right? So how do we build such models? That is something we are building at SML. We are also looking at several other use cases. For example, can we accelerate speeding up, say, the case resolution in in our courts? Of course, LLM is not legally supposed to make the decisions, and I don't think it's a good idea either. But it can assist the humans in coming up with relevant documents, in grouping together similar cases, in finding relevant, previous citations, previous judgments. So these are the things we are working on. We are also working on, say, speech-to-speech translation so that we can automate dubbing. There are several use cases that we have.
thank you, sir.
Sure.
Sir, I had a question specific to LangChain. So,
Sure.
Since this is uncharted territory for me,
Sure.
so is LangChain essentially a multi-agent framework? Can we put it like that?
LangChain is not a multi-agent framework in the sense that it is not the only thing it does. Agent is one of the features of LangChain. Okay. And there they provide multi-agents also. Now, if you want more dedicated multi-agent frameworks, I think there is Crew AI, which is built on top of LangChain. So there are some, see why I'm saying so is that because as the time progresses, LangChain has a much larger, it is much more broader. So the developments on agents alone might not be as updated as compared to a dedicated library for agents. That's why I'm just mentioning that LangChain is not just agents. It is one of their core features, yes, but they have other features as well.
So, could you share some perspective about how we can implement LangChain to build multi-agent framework to solve specific tasks like handling software and other stuff? I mean,
Yes, yes. I see a few things here. So one thing is that we need these agents to call APIs, right? Because as we said, let's say some company, let's say Make My Trip wants to automate this agentic workflow, then Make My Trip should tell first the LLM that what are the APIs it uses when you click on certain buttons, right? You want to automation, right? You want automation instead of the manual thing. So you should have this relevant APIs exposed and the relevant signature of the API. Signature means the function call, right? And the LLM has to be trained to handle that. That is one thing. Second thing is that, yes, it should be able to call these APIs. Third thing is that sometimes there are certain agents, just like the debate agent we were seeing, you need to search the internet. So then it has to be equipped to search the internet. If it is a YouTube summarizer, then it should have access to YouTube. It should be able to access the YouTube API, get several actions. Second thing is that so let me put it this way, because agent is a very broad scope. So currently you get your outputs in 3 seconds, 5 seconds. You get instant outputs, right? But let's say if you want to get an Oscar-worthy movie script and it's okay to wait for 1 week to get that, will we be able to do that? We should be able. We are fine with that, right? I mean, that's a reasonable delay if it's an Oscar-worthy script. Which means using the same LLM, can I interact with it during the prediction time in a manner which is substantially different from what we currently do? Say, if we incorporate some planning algorithm, if we incorporate ways for us to interact or modify the system output in between, right? Then the agents can enable to do that. These researchers are in the nascent stages. There are some preliminary research on this, but these are areas we can see. So agent as a concept has a lot of potential. You can do a lot of this, as I was mentioning, because currently we are assuming that we need everything instantly, or it is actually a limitation of the architecture, the autoregressive architecture. But these architectures also change. That's why we don't call them transformers, we call them foundational models, because tomorrow it can be a different architecture. It can be a different way of training the models. Even within transformers, there is something called as non-autoregressive models, which are completely different from autoregressive models. Then on top of it, we can build a lot of inference time strategies, a lot of inference time planning that enable you to behave these agents differently. So you might have heard something called a chain of thought, tree of thoughts. So these are very early stage planning, or let's say very rudimentary planning, if at all it's planning. But these basically, keep on enriching the context for the system to take better decisions. So there are different ways agents can handle. You can also think of different scenarios. You can bring in game theoretic principles. For example, what if I do here we were having a debate. So you had people with opposing views. So what if you put people with not just opposing views, but also there are supporters, there are popularizers, right? Or maybe a conspiracy theory. So depending on the use cases, I can have these different roles or use cases that enable me to get different outputs. So this is quite large. There are technical challenges, there are communication challenges or communication design required. So it's more not just the AI, but the UX also is important. It's also about human computer interaction, how humans want to be in the loop, when humans have to be in the loop. So it's quite broad. There is enough, there is a lot to explore there. So does that answer your question? Or all I wanted to give you was little pointers here and there.
I was actually slightly confused as to how does LangChain enter this area? Like where exactly does it take off? I mean,
yeah. So if you look at LangChain is just providing you nice abstractions. Okay. So let us look at the very basic agent that we just saw today. What all does it require? It requires a memory to keep context, because your LLM cannot keep context currently, right? Your chat GPT does not have a context. You have to provide that in your prompt, whether you use OpenAI's agents or assistant, or whether you use LangChain agent. That memory has to be provided as input in a prompt, and someone has to keep track of that memory. That is one thing. Second thing is that the tool calling I was mentioning, right? Someone has to define how should the tool be called once the LLM decides to call it. The LLM can only output a token currently, right? If you look at ChatGPT, it will only output string. Then from the string, how to understand that string means calling this API with this value. That is called as tool calling. It is an abstraction. So memory is an abstraction, tool calling is an abstraction, right? Then At what point, how should the system use it? In what all ways system should use it? How many times a system should use it? This is typically done by some algorithms called as React or chain of thoughts. So these are also nicely implemented in LangChains. And they have put together and shown that you can do, by combining them in different ways, you can come up with different type of agents. Now it also enables you to extend to new type of agents by combining these kind of functionalities. It also enables you to define your own tools. It also enables you to define your own way to handle the memory. It also enables you to handle your own way to, just like chain of thought, if you have a way to do it differently, you can tell that, you can implement that in LangChain. So LangChain provides these abstractions so that it is easy for you to reuse a lot of these components.
Right, understood. Thank you.
Yeah.
Hello.
Yes,
So, sir, I think we don't have any more question.
sure.
Thank you, sir. Thank you for such an amazing session. It was really great.
Thanks
So
a lot.
I think it deserves some round of applause, right?
Okay. Thanks everyone.